Hello guys, this is prime concept, right? We have another problem still under electricity. We want to find the equivalent resistance here across the terminals AB. So across these ends, we want to find the equivalent resistance. Now, when you want to find or solve for equivalent resistance, what you always do is you start behind the terminal. You start behind. Now, we are looking for the equivalent resistance across AB. So we don't start resolving from this point. You have to start from the end and start resolving gradually till you get to terminal AB. So we're going to do just that. Now let's start from this end. If you look at this, obviously this resistance or this resistor and this resistor are obviously in series. If you watch, it's a continuous flow. So they are connected. So these three resistors are in series. So I'm going to tag that as my R equivalent 1. That is to say the first equivalent value I'm getting, which is going to be, since the three of them are in series, I'm going to add their values. So I would have 2 plus 2 plus 2. So if I add up these values, it will give me 6 ohms, right? So I'm going to redraw the circuit. Since these three are now a single resistor, so I'm going to change that. So we'll then have a new circuit like this, and this becomes 6 ohms. So this is the new circuit we have. And the next thing you would observe is that this value, this resistor and this resistor are parallel to each other. So since they are parallel, you need to resolve, get the equivalent. So I'm going to call this equivalent 2. So my R equivalent 2. Now I taught a very simple way of getting equivalent resistance for two parallel resistors. And the simple thing to do is their product over their sum. So the product is going to be 6 multiply 6 divided by their sum, 6 plus 6. So when you have two resistors in parallel, you want to get the equivalent, you simply do their product over their sum. So what do we have here? We have 6 by 6, which is 36, divided by 12. 36 divided by 12, I think is 3 ohms. So we have 3 ohms. So I'm going to redraw this circuit. So these two resistors has now become 1. So I'm going to eliminate this part. We have only one resistor here. And the value now is 3 ohms. Now, if you watch again, you notice that this, and this are in series. So we need to get, I'm going to call this R equivalent 3. That's my third equivalent. So I'll add them up because they're in series. So it's going to be 3 plus 3 plus 4. So if I add up these values, I'm going to get this 6 plus 4, this 10 ohms. So this 3 has now become 1. So I'm going to redraw the circuit. I'll rub this and leave it as just 1. So this is what I would have now. This is what I have. And this value is 10 ohms from what we got there. The next thing you would observe again is that these two values are now in parallel again. So I want to call it my R equivalent 4. So R equivalent 4. Now, since both of them are in parallel, you simply do the product over their sum. So the product is going to be 10 by 10 divided by 10 plus 10. So 10 by 10 is 100. 10 plus 10 is 20. So this is going to be 5. So this is 5 ohms. So these two resistors again will become one single resistor. So I will rub this side. I'll rub this. So this is the single resistor we have, which has a value of 5 ohms. The next thing we can clearly see now, a very simple circuit, that this are in what? In series. Now how do we get the equivalent? So I'm going to call it the final equivalent. So R equivalent, because that is what we are looking for. So the equivalent is going to simply be 5 plus 5 plus 5, which is going to give me 15 ohms. And this is my equivalent resistance for this circuit. Now, when you see circuits in electricity, don't be scared no matter the size. Just start handling them one by one, and you'll notice that complex of big circuits was reduced to a very simple and small circuit. So with this, if you want to now draw your final circuit. This is what you would have. This is what you would have. So this is 15 ohms. So this is the final circuit for what we have, and our answer is 15. I believe this concept is very simple and very clear. Thanks for watching my video. Do subscribe to my channel, like, and share with your friends so that they can also benefit. Remember, this is Prime Concepts. Thank you.